Okie dokie, and we meet once again. This is video number 4 of our Move Advanced Smart Contract Language tutorial. In this video, we finally start with global storage operations in Move. This is the video that is going to get you more familiar with storing data in a blockchain using a Move smart contract, okay? We are going to start by taking a look at how we define structs and how can we pass values, update those values, delete and read those values. Let's not waste any more time. Let's go. For this one, I am going to start with a whiteboard. You know me. Why? I want you to picture on your mind, every time a user calls a smart contract and passes values, we need to store those values, how we are going to be referencing value to account. In this demo, we are going to build a smart contract that is going to stake and unstake tokens, but it's not going to stake the actual tokens. What it's going to do is just going to update a property inside that struct with the value of the tokens that the user is going to stake or unstake. When we define a type ability, we will define the struct name and the ability. One of the abilities is key. What key is going to do is going to allow me to reference a value. I will be able to pass a value to that stake pool that will associate whichever value we stored in that stake pool to an account. If account 1 calls a function to stake and it passes an amount of tokens, we will obtain the amount of tokens when we execute that function. When that user executes the function, we will pass those values referencing this account ID. So we know that account 1 staked 100 tokens. Why? Because we are now referencing that account address. This will be the key to get to this particular storage, okay? With that being said, this is not the only type ability that we have in the struct. We have other abilities, but let's go ahead. I want you to understand that every time we have a signer making a call to stake or unstake or retrieve token balances from the staking pool, we are going to be passing the account address as the ability, as the key. So then we can find the information for that user, in this case, the amount of tokens that it's staked on that pool. I just want to give you this quick whiteboard so then you understand how we reference data to accounts in Move, okay? Now, let's build a module, and I am going to call this storage demo Move. And we begin. We are going to type module net to dev addr, and we will call this storage demo. Awesome. The first thing I'm going to do, I'm going to build the struct. So I'm going to say struct, and we will call the stake pool, okay? Has key, because we want to define the key, which will be the account, so then we can associate the balance in the staking pool for that account. So I'm going to say amount. This will be the property inside the struct, and the amount type is going to be U64. Awesome. Now, when we deploy this module and we build our decentralized application to do staking, we have to initialize the storage per account, which means what? All I have to do is provide some initial values, so then that key for that particular user, it's generated and it's assigned. So we have storage allocated for that user in the struct. We're going to say function, we are going to add a user. So every time the user joins the staking pool, first it needs to add the user to the pool, which means that we have to provide those values. I'm going to say add user, and the only thing that I have to pass is the account, the signer. I'm going to pass a reference to signer, and you'll see why, okay? Now, I am going to initialize the storage for that particular account that makes the call. And that's how you initialize. That's how you first sign in onto the staking pool, okay? So we are going to define amount. This will be U64 because that is expected to be the type that I need to pass. Then we will provide an initial value of 0. Okay, so we just initialize that pool for that particular user. Now I am going to do one of the first operations in the struct. And one of the operations in a struct, it's called move to. Move to, what it's saying is that this value, let's move it to the struct. Let's pass those values so that we can store that data in the contract, okay? Very important. And we will define the first thing that I have to pass in this move to will be the account. We need to pass the account because this will be the key to then reference the data. So I'm going to say account, and then we'll say comma. And now I have to define the property and pass the value that I will be updating inside this property, which will be amount. All we have to do is we have to create that right here. So we have to add that stake pool. And inside the stake pool, we are going to pass amount, right? Which will be the amount that we are initializing this particular entry in storage, okay? Once we run this function, we should have storage already allocated for that particular user. How do we test? You know me. What I'm going to do, I'm going to create a test, and that test is going to do the following. Function test function, boom. But now I have to pass a signer because it's expecting a signer, so then I can reference data to that account, which means that I have to create one demo account or test account right here. So I'm going to say here, and we'll call this user, and we'll create this value right here, 123. That's the address of that particular account. We will pass user as the value that I will be passing into the function, and this will be defined as a signer. Now, when we work with structs, if we are executing certain operations inside the struct, which is not move to, but there's other operations that we have to define, we have to acquire the struct. So we have to say to this function, by the way, you are going to be borrowing data from the struct, and you are going to be removing data from that struct, which means that I have to acquire the state of that struct and pass it into the function. So I can say acquire right here and pass the name of the struct, stake pool. Once I do that, I can now define my expressions. Let's create that storage for that user. I'm going to say add, I'm going to pass that function. Let's call this, and I am going to pass the reference to user. Okay, so we are effectively passing this reference right here. Beautiful. This should do it. And by the way, we are going to minimize a little bit. Perfect. This should do. But we want to make sure that we were able to add that user storage and initialize that pool for that particular user, which means let me assert. I am going to assert that I have that storage allocated for that particular user. It's initialized. Even before I do the assert, I have to build a function that is going to retrieve the values. I can confirm that the amount for that particular user account, it's set at 0. I'm going to say function read pool. And now we are going to pass account. We're going to say account address. This will be the address. We don't need to pass the signer. All we have to pass is the address, okay? And this will return U64, but it also needs to acquire stake pool, the struct. So we have to acquire stake pool. Why? Because I am going to be using a function that is going to borrow values out of the pool. It's going to read the values out of the struct. So I'm going to say borrow global. This will be another operation besides move to. We mentioned it's going to store data. It's going to pass data into the struct. Borrow global is going to obtain, is going to read the data and store that data in a variable. We can pass it to a variable. And we are saying borrow global. Now we pass the type, which will be the struct stake pool. And we now pass into borrow global the stake pool, the name of the struct, account. This is how we read and find the information based on the key, because we're passing that account. And now from there, I am going to grab the amount. So we are just going to call this amount. By doing this right here, it is actually returning U64 because this borrow right here is going to receive value. So this is effectively going to return. I don't need to declare a variable to grab the values from borrow global. I can just use this to return the data. Once I got that, now I can invoke that function down here. Okay, so this read pool is going to obtain those values, and now I can read pool right here, and that read pool down here is going to return me the value of whatever the amount is. Okay, so on the read pool, I can pass signer. Remember on signer video, we have to pass signer, and then we'll say address of. That's how we obtain the address of that signer. And now we have to pass the reference to user. By doing that, we should obtain 0 as the return. When we create that user, remember, we are just populating that space, that storage with 0. 0 will be returned once we read pool. So we are effectively using this function that we're calling. It's going to obtain the address, then the address will be passed to read pool. The return that we obtain should match 0. If it does, perfect. If it doesn't, we just want to throw an error code. And finally, we want to print. So we want to say print, and let's print to make sure that the function got successfully executed. Okay, so we are going to say print, and now I'm going to say reference UTF-8. We're going to say byte, and we pass user added successfully. Beautiful. And that should be it. Okay, so this is the first function that initializes the storage for that particular user account and just adds the amount to be 0. Okay, now because I am invoking signer, that means I have to import those modules. So I'm going to say test only, and we are passing use std. We'll say signer, that's the first one. Then the second one, test only, use std debug print, okay? And finally, I need string, okay? Because I need UTF-8, so I'm going to say test only string, and we'll say UTF-8. That should do it, okay? Let me give it a shot. Let's see what happens. So I'm going to say here, move test, and we have an issue. What is the issue? Assert argument expected 2 arguments, but got 1. Why is that? Oh, I see why. Okay, hold on. The issue is that I did not close the argument here, the read pool. So check this out. This should do it. Let's do it again. Beautiful. We were able to update the storage. The user was added successfully. Now, how can I update the value inside the struct? So let's do that. For that, I am going to create another function, stake. So let's say the user has staked. It has added tokens onto that pool. With stake, I also have to pass the account as a signer, but it's only the account address. So I'm going to grab this. I'm going to pass it right here, and it's also going to acquire the stake pool. Now, first of all, I have to obtain what was the current value in the struct, right? Because if the user already staked some tokens, we want to grab what's existing, and we want to update with the new deposit, with how many tokens has the user deposit on the new staking action. I don't want to delete what was left. We want to just update. So in this case, I first have to obtain the value. So I'm just going to say entry, and we are going to be reading that from the struct. How do we read it? We are going to borrow global, but here's the thing. Borrow global without mute is immutable, which means that I cannot update whatever value I obtain from this return, which means that I have to say the following. I am going to say mute, and we are going to declare this. We'll call borrow global mute, and the rest is going to be very similar. Grab this, boom, and put it here, and we'll close this expression. And now I can dereference this variable. So I'm going to dereference. Remember last video when we talked about mutable and immutable, we are dereferencing entry, and we are adding the existing entry value, dereference because it has to be dereferenced. And we are updating the value, adding, let's say the user decided to add 100 tokens. So we're just grabbing what's existing on the pool, adding 100 tokens, and that's it. That's all I have to do, okay? Now, with that being said, I am going to continue down here. Now we are going to stake. I have to say stake. We'll pass once again the argument, but in this case, it's not expecting the signer as the argument. It is expecting the address, which means that I have to obtain that address. How do I obtain the address? Well, same way I did right here. So let's just take opportunity of this statement right here. I'm going to copy this, and I am going to say under stake, I am going to pass signer address of user, okay? Beautiful. Now, once I stake, I want to do a similar verification. I want to make sure that now the pool has 100 tokens. So we are going to do the same assert as we did on the first demo. Now we are staking, we're passing the arguments, and now we have to confirm that it's 100, right? Because if the user has 0, initially has 0, now it should have 100. And we will print user stake 100 tokens. Beautiful. Now let's see what happens, okay? There we go. We created the account once again, staked 100 tokens. Beautiful. Now let's unstake the tokens. Quote, unstake, okay? Let's go back. So now if I want to unstake, I am going to do another function. Let me take opportunity to copy this one because it's going to be very similar. As a matter of fact, it's going to be the same. This will be unstake, right? All I have to do in reality, it's just, when we do unstake, it's just going to remove all the tokens, which means that I have to say entry is 0. Okay, so we effectively unstaked all the tokens, and that should be it. Everything else is the same. Like we are still borrowing, but now we are updating the value to be 0. That's it. Okay, let's add that instruction right here. So I'm going to copy this. I'm going to let me close this expression. Now we are saying unstake. Okay, and now we should see 0 here, right? And now I can say unstake from pool. Let's give it a shot. See what happens. Beautiful. Okay, so we were able to create the account. We were able to stake 100 tokens, and then we were able to unstake all the tokens out, okay? Awesome. One last thing that I want to show you, and this is how do we remove data from the struct? How do we delete the reference to a particular user account? There's 2 ways, but I want to show you the first one. I'm going to say function remove user, and this one is going to invoke move front. Very different from this, which is going to add data to the struct. Now we are removing data, which means that we are moving from the struct, okay? I got to say now the same. I'm going to say account account, signer. I'm going to pass this as the argument. Different from move to, you can see that I didn't have to acquire the stake pool, right? Not like the other functions. I did not have to do acquire. Anything but move to requires this statement, acquire stake pool, to be invoked on the function, okay? Which means that I have to do this, and that's it, okay? Now, let's remove the user. So we are saying move from, and the statement is going to be very similar to the borrow, but I'm going to say stake pool. All I have to pass as the argument is the address of the account that is going to be removed, which means that I have to pass this right here. We're just going to take the opportunity of grab this, so I don't have to type, paste it right here, and we have to change this to be account, okay? And this doesn't have to be the reference. This move from is going to return a value because it's not saying delete, it's saying move from, which means that we are going to receive the state of that entry in the struct. And in move, we cannot just leave it as is, right? Because I have to either do something with those values. Let's say we are going to pay out the user. We can grab those values and pay out the user and then close the account. Or we can drop the value. We can drop whatever we receive from that call. We have to destroy the values when we are doing the execution. This is part of move memory safe execution, where we confirm that we are not going to do anything with that. So I have to make sure that I can drop it before I can do something else. So I am going to receive that data and it will be stored in entry. I have to do something with it. I can say stake pool and I can define amount. I can invoke a struct this way, and I can update the property inside the struct by passing this argument inside here, okay? So I am effectively updating inside the stake pool amount with entry. I can do that, and that should be fine. But again, it's not going to create the entry in the struct. That's fine. I can then do the following. I can say amount, and I can just pass amount, and that's it. All I wanted to do, I wanted to make sure that I can use the value so then I can delete the entry, but I still have to do something with that value. Else move, when I try to compile, is going to fail because I need to use that value for something. And let's give it a shot. Let's see what will happen. As a matter of fact, because I am returning amount, I have to make sure that I add that type, U64, okay? Boom. And now let's give it a shot. Let's see what will happen. So I am going to do remove user, and we will pass the value, same as what we did here with add. Now it's going to be remove. Boom. Okay. But I want to make sure that the account was removed. And one way that we can confirm is we have another operation that will confirm to me that an entry is either available or it's not available. So let's do a function, right? This function is going to confirm user. And this function, all I have to pass is the account value, and it's going to return Boolean, okay? Which means what? If there is data associated to this account on the struct, it's going to return true, else it's going to return false, okay? So then we can do an assert and make sure that we were able to remove that account. So I can say here, exist, this is the ability, exist, and all I'm going to do is pass the stake pool and the account. And that's it. That's all I have to do. Now with this, I can effectively make the assert. So I'm going to say first remove user. Then I am going to grab this, take the opportunity, copy it, add it here. And we are saying confirm user, right? And we'll pass the address, and we have to make sure that this is false. That means that this user account does not have any data in that storage, which tells me that was able to remove it successfully, okay? And finally, we want to add a print. The print is just going to say user removed from stake pool. Beautiful. Let's run it and let's see what will happen. And we are finding that signer is unbound. Oh, I think I know why. It's because I am passing it as test. It's not defined in the module. So I'm going to say use std, and we'll say signer here. Let's see if that does it. That was it. Okay, so yes, it was because it was expecting signer here, but I was just passing reference to signer from the test function. So I have to place it in the module, not in the test. Good, so we were able, go back, we were able to see that it was able to add the user, it was able to stake the tokens, it was able to unstake from the pool, and finally it was able to remove from the pool. Finally, what I'm going to do is I am going to show you another way that we can implement this without having to define this entry, because again, like I mentioned, we have to use the value that has been provided when we do that execution, when we do that move from, and then we'll do something with the value so then move doesn't complain. So when it compiles, it's going to complain if I don't use this value for something. Another way that I can do it is I can destroy that value. I can drop. That is another type ability inside the struct. So we have to define the struct has key, but then the type also is drop. So now with this, I can tell move any value, allow it to be destroyed. If I am not using that value, destroy it as you execute, compile and execute. But now I don't need to use this. I can effectively delete this, and I can also delete this right here. Now what's going to happen, instead of me returning U64, all it's going to do is going to delete whatever is obtained from here, and everything should be great. That's about it. Let's hit it up and see how that goes. Beautiful. Okay, we were able to do the same thing by dropping the value, not have to do anything with that value. Okay, awesome. And we are done. Alrighty, this is the end of video number 4. On video number 5, we are continuing our journey in the storage section of a move module. We are going to take a look at type abilities in the struct, and we are also going to start referencing struct to other structs. We want to make sure that we can fully understand how can we move data around in the module, and we can also assign type abilities that will allow me to copy those values and move those values to another struct. Okay, well, that's it for this video, and see you on the next one. Let's move.